Hello everyone, welcome to a new session. We have studied about lens, the working principle of the lens, construction of ray diagrams for locating the image and predicting the nature of the images using a concave lens and convex lens. Your concept and learning become more clear when you apply this concept what you have studied in our own real life situations. So let's have a question answer session based on the concept we have learned in our previous videos. So watch those videos for better understanding and clarity of the concept. So let's begin. Let's begin with exercise 5B of your concise physics textbook. Couple of important diagram based questions are given there. Let's try to solve it. Okay, so let's begin. We start with question number 5. A diagram is given there. Question number 5, you can see on the screen, an outline of the lens is given. An outline of the lens L dash is given. Its optical center O. An object is placed between, you can see the O dash, the mark O dash, O and O dash. Clear? The points are given O and O dash. An object is lying between this O and O dash. For our convenience, O and O dash is given there. Let us take this point as okay, mark it as C. Okay, let it be C. Optical center as C, since O and O dash is already taken. An object is lying between C and O as per our question, and a ray of light traveling parallel to principal axis. You can see it is after refraction, it converges and passes through the optical center. Sorry, passes through the O dash. Clear? So O and O dash is not mentioned what it is. We have to find out. So this is the questions. The first part of the question, name the lens. So you can see, name the lens L dash. It is an outline is given there. So you can see, looking at this diagram, the light rays converging. So it's a converging lens. So what is a converging lens? This lens has got converging action on light rays. So definitely we can name it as convex lens. What it is? Convex lens. Clear? So convex lens. So we can complete the outline of the lens. We can make a convex lens confidently, thicker at the middle, thinner at the edges. So first part of the question is over. We have attempted it. Second part of the question, what are these point O and O dash known as? So O and O dash is known as, obviously, since the light rays after converging, it passes through this point, we can call it as principal foci. Principal foci. So O and O dash are known as principal foci because light rays after refraction passes through this point. That point we call it as principal focus. Okay. Now what you have to do? We have to complete the ray diagram. In the third part of the question, we have to complete the ray diagram. Clear? Let us try to complete it. So you know the object AB. The object AB is lying between optical center and principal focus. This is the last case of the convex lens. We have studied it. The special case of convex lens when the object is so close to the lens such that it is lying between optical center and principal focus. We know the case. We have studied. So what happens? One ray of light, it is already completed. We have to consider the second ray. So the second ray of light passing through the optical center passes undeviated. Okay. It reaches the eyes of an observer. An observer is observing from this point. Clear? So where the light rays will meet? The light rays will appear to diverging from a point. How do you get it? You produce it backward. Produce the light rays backward. Let us produce it by a dotted line, straight line. Use scale and pencil. Okay, I have produced the meeting point. The point of intersection is the position of the image. Dotted line, we can get an image virtual, erect and magnified image A dash B dash. So the diagram is completed. Clear? So we are getting a virtual, magnified, erect image on the same side of the object. Clear? Now that part is completed. Third part is completed. The fourth part, state the three characteristics of the image. What is the characteristics? What are the characteristics of the image formed? You can write it. Now what type of image it is? It is virtual. Virtual images are always erect or upright, erect and magnified. Magnified means bigger than the size of the object. You can see the image is bigger than the size of the object. Clear? Okay. And the fifth part, the last part, name the device in which the action of lens is used. Where you can find the action of this type of lenses? We have studied in our previous classes, right? So this type of lenses in this manner is used in case of reading lens. Reading lens, it is used as a reading lens or a magnifying glass or a simple microscope. Remember, this is the action of a simple microscope. Simple microscope. So use is very important. It is usually asked in board examination. Clear? So that part of the question is over. So I hope it is clear to you. You got the points clear? Okay. Now let's move on to question number 6. Another question number is given there. Let us move on to question number 6. We are discussing diagram based question, important diagram based question from exercise of 5B of your concise physics textbook. Question number 6. Let us see what is question number 6. Again, an outline of the lens is given there. A lens, okay, its optical center is being marked as X, point optical center O, principal focus another on another side, it is equidistant from the optical center. Okay, choose proper scale and mark it. It is O dash. An object is standing beyond the principal focus. An object AB is standing beyond the principal focus. We can see on the board. Okay, a ray of light traveling parallel to the principal axis. After refraction, it is diverging. It is diverging. You can see. Clear? So this is the outline of the lens given there. This is the ray diagram given. You have to complete the ray diagram. Okay. Now let us try to complete it. Okay. So name the lens. So you can name the first lens. See, looking at this diagram, you can see the light ray is diverging. So since which lens has got diverging action? Concave lens. Definitely concave lens has got diverging action on light rays. Clear? Second part of the question. Let us see what is second part. What are the point O and O dash called? O and O dash. Very simply you can answer it. They are principal foci. Principal foci on either side of the lens. O and O dash equidistant from the optical center X. Clear? Okay. Now complete the ray diagram. The third part, you have to complete the ray diagram. Okay, let us complete it. A ray of light traveling parallel to principal axis. After refraction, it is diverging. First of all, we will complete the outline of the lens. A concave lens. Let us try to draw a concave lens. Thinner at the middle, thicker at the edges. Okay, completed. All right. Okay. Now it is diverging. When you produce it backward, it meets at the point O, or it appears to diverge from the principal focus. Now another ray originating from the point of an object passing through the optical center passes undeviated. Clear? Don't forget to mark the direction of light rays. So the point of intersection where the image is formed, you can see the point of intersection. So the image is formed between optical center and principal focus. What type of image? A dash, B dash image. The location is between optical center and principal focus. Clear? So the ray diagram is completed. Perfect ray diagram is completed. Clear? Now we have to state the characteristics of image. Third question is completed here, ray diagram. Fourth part, you have to write the characteristics. Now all of you can say the characteristics looking at this diagram. Okay, concave lens always form virtual image. Virtual images are always erect or upright and diminished, smaller than the size of the object. It is diminished. So concave lens forms always diminished image, virtual, erect and diminished image for all the position of object. Irrespective of the position of the object, a concave lens forms virtual, erect and diminished image. Keep it in mind. Okay. So this question number 6, it is completed. Now what is left? One more add-on. Can you name the use of such a type of lens? Question is not there, still an add-on question. Can you name the use of this lens? This type of concave lens is used in spectacles for the correction of short-sightedness or myopia. Okay, so I can write this type of arrangement lens, concave lens in this manner is used in spectacles. Spectacles for correction of myopia, one of the eye defect seen in children, myopia or short-sightedness. Clear? Okay. So you got the points clear? Moving on to question number 7, you can see a diagram on the screen, an incomplete ray diagram. You have to complete it. Our task is to complete the ray diagram. An object is placed, an object AB is placed between optical center and principal foci F1 and F2, and you can see a converging or a convex lens. First, with the help of two rays, we have to complete the ray diagram and you have to locate the position of image CD and also mark the position of eye from where the image can be viewed. So let us first of all we will complete the ray diagram. So first, a ray of light traveling parallel to principal axis. After refraction, it will converge and pass through the principal focus. Clear? Mark the direction of light rays. A ray of light traveling through the optical center passes undeviated. Clear? And now an observer who is watching from here, we can locate the position of eye. So draw the eye. Okay, this is the position of eye where the light rays are falling on the eyes or reaches to the eyes of an observer. For him, light rays, the image or the light rays appear to coming from somewhere here, so that we produce it backward. Clear? Produce it backward. So I have produced it backward with the dotted lines and the point of intersection where the image is formed, image CD. So they have clearly mentioned it, CD. So name the image as CD. So image is formed on the same side of the object. So we know this is the case when the object is lying between optical center and principal focus. This is a special case of a convex lens which is used as magnifying glass or as reading lens. The last case of a convex lens. This is very, very important, usually asked in the examination. Okay. So the first part is clear. We have completed the ray diagram. Okay. Now we have to state the three characteristics of the image. Okay. So characteristics of image. What are the characteristics of image? So this type of image represented by dotted line. These are virtual images. Virtual. They are erect or upright, erect and magnified and magnified. Clear? Image is magnified or bigger than the size of the object. Okay. So this lens is used to read letter from a book or to observe the tiny parts of a wrist watch. Okay. So that part is clear to you. So take it pen and pencil and draw the ray diagram with me. Just merely watching the video of no use unless you take down the notes and practice it with me. Okay. Yes. Now moving on to question number 8. Let us see what is question number 8. Again a ray diagram. We have to complete the ray diagram. Okay. A convex lens is given there. You can see a convex lens. a convex lens with optical center, mark its optical center exactly at the middle, geometric center of a lens. A lens L is given with the principal foci on either side f1 and f2 on either side of the lens. An object is lying just beyond f1, an object AB. Okay, so it is lying in between f1 and mark center of curvature, its center of curvature, that is mark it as 2f1, here f2, take the equal distance from the optical center, mark it as 2f2. Okay, it is twice of the focal length, known as center of curvature of the lens. Okay, now the object is lying in between f1 and 2f1. Locate the position of the object f1 and 2f1. Okay, now we have to complete the ray diagram. The first task, using two rays, we have to locate the position of the image by drawing ray diagram. Okay, you know the case, remember the case, when the object was at 2f1, we got an image at 2f2 on other side, which is of the same size of the object. Clear? Now I am taking the object towards f1. What will happen? The position of the image will shift from 2f2. Okay, position of the image will be shifting from 2f2. It will move away from the optical center and it will be magnified. At 2f2 we got, when the object was at 2f1, we got an image, remember we got an image exactly at 2f2 which is of the same size of the object, in real, inverted and same size of the object. Now I am taking the object from 2f1 and moving it closer to optical center such that it lies between f1 and 2f1. Then what will happen to the image? Image will move away from the 2f2. Okay, so let us complete it. Let us see what happened. A ray of light traveling parallel to principal axis. After refraction, it will travel through the principal focus. Okay, a ray of light traveling to the optical center passes undeviated. So where it is meeting? So it is meeting here. Okay, this is the meeting point. That is, you can see the image here, image formed A dash, B dash. Clear? So we got an image which is beyond 2f2. Clear? Beyond 2f2. So we have completed the ray diagram. Clear? So where this lens is used? In cinema projector or slide projector, this arrangement of lens is used. All of you remember the use of lens, very important. Okay, so we have to state second part, first part is completed, drawing the ray diagram, drawing the ray diagram part is over. Now the second part of the question, what is that? State the position of the image with reference to the object. So the object is beyond 2f2. So I can write beyond 2f2. Obviously it is beyond 2f2. Describe three characteristics of image. Third part of the question, three characteristics. So convex lens always form real image, real, inverted, you can see inverted, upside down, inverted and magnified. And magnified. Clear? So magnified image, bigger than the size of the object. Okay. Now the fourth part of the question, describe how the distance of image from the lens and the size of the image as the object is moved towards f1. Suppose you are bringing again the object moving towards f1, what will happen? So the image will move away from optical center, move away from 2f2, and what happens? The distance of the image increases, distance of the image from the lens going on increasing as you are bringing the object closer to the lens, and the size of the image also slightly increasing. Okay, so distance increases, distance of image I can write, distance of image increases, distance, and size is also increasing, size also increases when you are taking the object and moving it towards f1. Clear? The points are clear to you? Now let's attempt a board question in the year 2015, a ray diagram based question. Question is like this: where an object should be placed so that a real and inverted image of the same size as object is obtained using a convex lens. So this is a case of a convex lens. Okay, so what is the clue given there? Where an object should be placed so that a real and inverted image of the same size as that of the object. Now you have to remember where the image is formed of the same size of the object when it is formed. When the object is placed at the first focus, when the object is placed at the at 2f1. Okay, image is formed on the other side at 2f2. I mean at the center of curvature of the lens. At the center of curvature, this 2f1 and 2f2 are known as centers of curvature of a convex lens. Okay, so remember that case. So let us try to complete it. First of all, let us draw a convex lens. A convex lens, mark its optical center. A ray of light passing through the optical center passes undeviated. We call it as principal axis. Okay, let's mark f1 first focus equidistant from OF1, that is we can mark it as 2f2 to f1. It is the center of curvature. On other side we have f2 equidistant from f2, we have 2f2. Clear? So that part is over. So draw a ray diagram for the formation of the image specified by the part 1. You can see in the part 1. An object, real inverted object image is formed of the same size as the object. This is the case when the object is placed at 2f1. So let us place an object AB at 2f1. Okay, object is placed at 2f1. So a ray of light traveling parallel to the principal axis. After refraction, it will travel through the principal focus. Okay. So slightly bend, let me make it correct because light rays always travel in a straight line. Use scale for drawing ray diagram. Okay, and a ray of light traveling towards the optical center. After refraction, it passes undeviated. You can see the image is formed exactly at a inverted image at 2f2, that is A dash P dash, that is the meeting point. Image which is of the same size as that of the object. There is no magnification. Okay, here there is no magnification because the size of the image is same as that of the object when the object is placed at a 2f1. Remember this case. Okay, 2f1. So 2f1 is also known as center of curvature. Center of curvature. Remember 2f1 is also known as center of curvature. So when the object is placed at center of curvature, we get the image real inverted. What is the nature of the image? Real inverted. Same size as that of object. Okay. So you got it? The points are clear to you? I hope by this time all of you are expert in drawing ray diagrams and completing incomplete ray diagrams. Our question answer session was helpful, I hope, helpful and understanding for you. If you like our videos, please subscribe our channel, do like and comment, and enable the bell button for further videos as notifications. Thank you very much. Thanks for watching.